The future value function is useful for finding an amount today in terms of what we'll have tomorrow given a rate of return. This applies to a lump sum as well as an annuity stream, or a lump sum today followed with an annuity stream. The syntax of the future value function is much like that of the present value function. The only difference is the FV and the PV are swapped. That is, when we look at the syntax of the future value function, as shown in row 8, or up in column E, we see that the FV indicates the function, followed by the right-facing bracket. You see the first argument is rate, number of periods, and payment. This is exactly the same as in the present value function. The only difference is we now have brackets with PV inside, and this is the reverse in the present value function where we'd have FV, and then of course followed by type. So the only difference is these two arguments, or these arguments are swapped. Again, if you're having a challenge with this function, the easiest thing to do is type your equal sign FV and place your mouse pointer over the FV portion of the syntax cheat and left click. The help menu will pop up with a description of the function, the syntax and the arguments, as well as the calculation methods. So let's start on this first sample cash flow. If we loan $100,000 today at a rate of 8% compounding quarterly, how much will the loan be worth upon maturity in 10 years? So as we want to know the future value, we're going to start off with FV, and our first argument is rate. We know that the rate is 8%, but it's quarterly, so we'll type 0.08 divided by 4. What this is saying is our periodic, that is each quarter, we're earning interest of 2%, but the annual unadjusted rate is 8%. Obviously, with compounding, the effective rate will be greater. The number of periods, well, we know that it's for 10 years, but again, it's quarterly, so we'll multiply. So we tell Excel that we actually have 40 periods in total. There is no payment over the life of the loan. There's just a lump sum at time 0, so we'll skip that argument. If you want, you can type in a 0 for payment, but we're going to leave it blank. The present value is the 100,000 that's indicated as a cash outflow. And the funds will be returned at the end of year 10, so we'll type in 0, or again by default we can just leave it blank since it's at the end of the period. We see that if we loan $100,000 today at 8% compounded quarterly, in 10 years we will have $220,803.97. In the second example, we're looking at if we deposit $10,000 at the start of the year into an account that pays 6%, how much will you have saved in 15 years? So we're curious to see that if we deposit $10,000 at the beginning of every year, how much will we have saved in 15 years? Now there's a couple of ways to read into this. We could say, well, at the beginning of, by the time we hit year 15, but the way we're going to look at this is we're going to save $10,000 every year, but that deposit starts at the end of the year, or at the beginning of the year. And then we're going to look at how much will we have saved by the end of year 15. We're going to start with our future value function. Our rate is 6%. And we see that there are no subperiods, so we can just leave this at 6%. Number of periods are 15. The payment is 10,000. Again, you do not want to enter a comma here. If you enter a comma in 10,000, you'll move on to the next argument, which is the PV. So we'll type in 10,000. The present value at time 0, we're going to say 0, because we're going to tell Excel that the payment's made at the beginning of the period, not in the end. So we don't need to tell Excel that we're receiving 10,000 at time 0 as well as deposit. Then we're going to type in a 1 for the type since the payment's received at the beginning. And so if we save $10,000 a year for 15 years, and we earned a rate of return of 6%, in 15 years we will have saved $246,725.28. So you can see the future value function is much like the present value in terms of arguments. We need to divide r by n, multiply, that is the rate, we divide by the number of subperiods. The number of periods we will multiply by the number of subperiods. Payments, if they're subperiods, we'll divide again by the number of subperiods. And the only difference is if we have a present value at time 0, we have the option of entering that, whereas the PV function we have in the future value.